Okay, this is a practical example on how to use the normal approximation to the binomial distribution. So it says, in a box of 200 beans, it's known that 35% of them are green. Using a normal approximation, estimate the probability that exactly 80 of the beans are green in a sample of 200. Now, a modern day calculator will give you the answer to this directly. However, the question says use a normal approximation, so you have to go through the process of doing that. So we'll define what the variable is. X be the random variable, the number of green beads in a box of 200. Then X is binomially distributed, N is 200, and P, the probability of success, is 35%, which we write as a probability 0.35. Using a normal approximation to the binomial distribution, we have that X is normally distributed. We have to do N times P, so it's going to be 200 times 0.35, because the parameters of a normal distribution are mean and variance. So we do 200 times 0.35, and the variance we need to do 200 times 0.35 times 1 minus 0.35, which is 0.65. Working those values out, we're going to get that X will be normally distributed with a mean of 70. And it's better to write the variance as the square root of this number squared. Okay, because you have to use it in the standardization process for the normal distribution. So this comes to 200 times 0.35 times 0.65 is 45.5. But we take the square root and square it, and you'll see why I've done that later. We require the probability that X is equal to 80. So you have to, in order to apply the normal approximation, we need two values. So we do a continuity correction. So 80 will lie between 79.5 and 80.5. So we're applying a continuity correction. So the probability that X is equal to 80 is going to be the probability of being between 79.5 and 80.5. And then using the standard normal of tables, where Z belongs to a normal distribution, mean of 0 and standard deviation and variance of 1, and use the standardization formula X minus the mean divided by the standard deviation. And then we get that X is normally distributed 70 times the square root of 45.5 squared. So what we're going to do is use that to put in there. So applying this formula to each of these, we get the probability of 79.5 minus 70 divided by the square root of 45.5. So you can see why I've written it like that. Z is greater than and less than 80.5 minus 70 divided by the square root of 45.5. The most common mistake is to put 45.5, not the square root. Working those values out on a calculator, we get the probability of being between 1.408 Z and less than 1.556. Now I like to use a diagram. It doesn't take very long to sketch a diagram. So mean 0, standard deviation 1. There's 1.41, there's 1.56, we want that area there. So we need to do phi of that particular value from the table minus phi of that particular value from the table. So it's phi of 1.556 minus phi of 1.408 from the tables, which gives me 0.9406 minus 0.9207. And we've been using tables there for Z is 1.41 for that one and 1.56 for that one. That gives me 0.019923 significant figures. Now, if we do the normal approximation, that's what we actually get. However, you can use GAlgebra or some other calculator to get to the probability calculator in GAlgebra. You open up a GeoGebra page and go to View and select the probability calculator, and then select the correct distribution binomial. And because we want between 80, we'd put 80 and 80 in here, so that's that one what we're trying to find. So we can see that the actual answer is 0.0196, or you can get it from this table up here, 0.0196. Okay, so using the GeoGebra probability calculator, we get that. These are the two values. Well, these are the values that we get. You have to put n is 200, p is 0.35, and you get the actual answer to be 0.0196. We got 0.199, so it's a fairly good approximation. This is the actual answer. However, this is very important. The question said use the normal approximation, which must be used if in an examination. Therefore, if you write this down as the answer, you're going to get no marks. Okay, so this has been a video to show you how to use the normal approximation in a practical example. I hope you've understood, and I thank you very much for watching.